I'm Karis. I'm 22. I have a 4-year-old son. I'm a singer-songwriter and got a C in science.
I'm Emma Rawlins and I'm a research scientist. My lab works on human lung development and how you build the lung in a baby. So today we're at the Gurdon Institute in the University of Cambridge. I'm Emma Rawlins. This is my laboratory and we're here to talk about the different tools that we use in my lab to study human lung development, so how we build our lungs in the embryo.
I'm excited to kind of get a insight into something that I know so little about but I'm so interested in a sense, because obviously I have a child, so the development of children or just people in general really intrigues me. Hello, you okay?
Hello.
How are you?
How are you?
I'm good, thank you. What's going on here?
Well, in here we have set up what we call the breathing-like device, and we're trying to mimic breathing-like movements that are present during lung development.
Okay.
So we come up with a tool to try to mimic that in the laboratory. So then we inject air in this in the chamber, and that deflate the membrane, and we can control all of that with the computer to try to make it in cycles. So I can just show you. So if we press play in the computer, that will immediately form the membrane to deform. It's very subtle. Everything is very transparent because we want that. We normally use the microscope underneath so we can see the cells.
So what actually is a membrane? Because I did science, but that doesn't mean that I'm good at it. Yeah. So what actually is a membrane?
What is a membrane? Yeah, it's a very thin layer of an elastic material, and I'm saying that it's elastic because it's a membrane that will deform when we apply like this. When we inflate, it's very similar to what happened, for example, in a balloon, that it starts inflating, and then if you remove the pressure, it deflates.
That is so good. It looks delicious. Is that bad to say? It looks so good. It looks like the most nice jelly sweet I've ever seen in my life.
I don't think we have received that description of that before, which is really nice.
I guess I'm just hungry.
John Russell is doing some cloning, which is assembling bits of DNA in bacteria, and the aim of the experiment is actually to use them for labelling cells in the developing lung so we can watch where they go live. So the idea is to turn the cells green, like green fluorescent protein, and then we have to follow them over time. But first he has to assemble a lot of bits of DNA together and put it into what we call a viral vector that allows him to infect the cells.
Thank you, Lucia. That was amazing. Thank you so much for showing us all about your research and your wonderful brain. Emma, should we go and have a little chat?
I think that'd be great. Why don't you come to my office? Let's go.
What I did was I listened to the backing track and I kind of let it give me a feeling of where I wanted to go. With this, I kind of do some singy moments, some rapping moments, because I feel that I say rapping is more like spoken word. But yeah, I just went with what I felt like, which was everything and nothing all at the same time. I look back at the notes that myself and Emma made, and it just inspired me to write about nature and ourselves. And our main message was that we're constantly developing ourselves and the earth, and that communication between ourselves and the earth, ourselves and ourselves, ourselves and each other, or the earth to itself, ourselves, everything, communication is key. I think we need to take it back to the start. I think we need to focus on what really tells us all apart. Tell me what it means to be human, think of who we are. Tell me how you feel being human, tell me who you are. I just want to thank everyone involved. Reform is a very, very big part of my life, and science and development is a very big part of my life, as it should be everyone's, subconsciously or consciously, especially because I have grown a child. So it really, really opened my eyes to a lot of things that I didn't understand.